Let's look at a problem. Doesn't seem too bad here. What can we do with this? Well, a good first question to think about is it geometric? Especially when we see something to the power of n, that's when we start thinking geometric. And also when n starts at 0, that's kind of another giveaway. That's not guaranteed, but it's a hint. So how can you think of this maybe as geometric? So can we say that this is equal to the sum n equals 0 to infinity of 1 over 7 to the n? Does that work? Yeah, that works. That would be like 1 over n to the 1 to the n over 7 to the n, which is 1 over 7 to the n, so that's good. So we'd say r equals 1/7. Absolute value of r is less than 1, so the sum converges. And it's even a nice, like we're starting at 0, we don't have any constant multipliers, so we can just use 1 over 1 minus r. So that'll be 1 over 1 minus 1 over 7, which is 1 over 6/7 or 7/6. How would I check that? Well, I could type the first few terms of this sum into Excel or a calculator. That would be 1 over 7 to the 0, which is 1. So that's 1 plus 1/7 plus 1/49, etc. And that should converge pretty quickly. And then what else can we say? What if it was the sum n equals 0 to infinity of something like 9 over 7 to the n? What could you do with that? Can we say r equals 9/7? Is this saying the sum of 9/7 to the n? No, because the 9 is not raised to the n, so we'll have to say nope. What do we do instead? Well, the 9 is just a constant multiplier, so we could rewrite it as 9 times 1 over 7 to the n, and rewrite that as 9 out front times 1 over 7 to the n. And then we're back where we started there. Okay, so sometimes we have to do a little bit of manipulation before we can recognize something as a geometric series, and not jump too quickly to just say, oh, I see stuff to the n, let me just call that thing r. Let's do another interesting one. Let's do the sum n equals 0 to infinity of, let's do 3x, let's try that again, 3x plus 18 to the n. So, is that geometric? Well, it has some of the hints of geometric. It starts at 0, has stuff to the n. So we're tempted to say that this is r, 3x plus 18. Now I made the point earlier that r has to be constant. 3x plus 18 does not look constant because if you change x, it changes. But the key is r has to be constant with respect to n. If I just choose an x and do this sum for all different n's, the x is not changing from term to term, so r here is constant with respect to n. So it actually counts as geometric here. I'm going to put an exclamation mark there, but I don't mean n factorial, I mean wow. All right, so that's r. So when does the series converge? If absolute value of r is less than, not less than or equal to 1, less than 1, so I can just copy r, 3x plus 18 is less than 1. And then I need to solve that. What can I say about that? I'd say like -1 less than 3x plus 18 less than 1. Subtract 18 from each part. So I'd get -19 less than 3x less than, what do we have there? -17. And then divide each part by 3. So we get -19 over 3 less than x less than -17 over 3. is where this sum converges. So for any value of x in that range, the geometric sum converges. What else can we say about that? Could we say what the sum converges to? Well, we've got all the nice hints here, or nice good setup. N starts at 0. There's no constant multiplier out here, so we can just use 1 over 1 minus r. So it would be 1 over 1 minus 3x plus 18. And we could even go graph that and see what kind of stuff happens. It'd take a little bit of doing to think about whether we're getting right answers there. So we're not going to stress it right now, but it's something that we'll want to do later in Chapter 8.